Hello and welcome to section 1.32. In this section, we'll apprehend a better understanding on functions and some similarities and variables that we have covered in section 1.31. Okay, let's go back and see what we did in this line of code here. And basically, we got to include IO stream. What this is doing is it's going to the preprocessor, looking for IO stream. And whatever the IO stream, whatever it contains inside the IO stream is placed out into this code, so we don't have to, so we can actually use the in and out stream for command input and command output. And then we have a prototype. The prototype is in the int add me, int a proto and int b proto. Now, the two parameters, A proto and B proto, can be anything you want. It can be just a bunch of gibberish. It can be anything because we're not going to refer back to it. But it's good to make it something that you'll understand. But we have to put the prototype before the main, and what it does is it tells the compiler, hey, I'm going to make a function. I want you to prepare yourself to look in lines of code for the definition or the commands I want you to run when I tell you to do this function. So once we actually started in the int main, we're using the two integer types of x and y. What this comma does right here is it says two variables with the same type. So we can do int x and y, or we can actually just do two lines of int x and int y. But for the sake of time and code, I put a comma into that. And then we have a command input, which is asking for the input of x, and then we're asking for input of y. And the user basically picks what their value is for x and y. And then we got cal, which is using namespace std is preventing us from having to type in std colon several times over and over. And it does the same thing for command input as well. But we got the function right here, add me x and y, with the end line inside of calc. So calc is going to be placing into the console the variable x and y, whatever function is down here, int add me x and y. So using the function x add me parameter int x and parameter int y, so we're placing in these two variables. So whatever the variable x is that the user inputted, and the parameter int y, whatever the user inputted, and we're returning back the x plus y. So this should get a return of a value of x plus y. And it'll place it onto the console, and then we'll get a pause so we can actually see it was done, and then the int main will return back as a 0. Okay, so let's go back and let's compile this. Or actually, we gotta do that first. And if we go up here, we can see integer type is assigned, and it's our default is long. So the max value we can do, we can type in to add like one of the variables. The max that user can input right now is 2,147,482,647, or the negative of it -1. So let's go back to the program, close that, Control F10, go back to the list, and we're going to put in 2147,483,647, and we're going to type in the same thing, 2147,483,647, see what happens. See, we can't go above that because the range would be above it, so it comes up with -2. And let's press Control F10 again once we open the program, and let's do 1 million this time. 1, 2, 3, 1, 2, 3. Let's see what happens when we do 1 million on both of them. And we should get 2 million, which we get because it's inside the range. Now let's say we wanted to add these 2,147,482,647 to itself. Then you have to find a variable type that can hold that type of variable. So we need to find something 4 to 5 billion value. So we can do unsigned int, but it might end up being above that 4 to 5 billion. So let's go with something a little bit higher than that. Let's go with probably long. Yeah, no, unsigned long. So that's a lot to type in for every int. We're gonna do a type def. So we're gonna come up here, type def unsigned long, and we're gonna put u long l, and we gotta put our semicolon at the end. And wherever we see int on the prototype, we're going to place in that u long, which stands for unsigned long. And we're not going to mess with the main, because the main is actually its own integer type of a return. Yeah, it could actually be u long, but we don't want that, because main is its own type of return type. So we're going to put u long, which x and y will both have the variable type of u long, which is unsigned long. And then inside the command input, we got x and y, which is used for input of them. And we got the command out, which is going to be adding the x and y with an end line. So this comes up above it. System pause, press any key, continue. And then the int main will return 0. And the program will close. Int add me, int x, int y. We gotta replace this to match the prototype up here. So you gotta put u long, and then it'll take the u long x and the u long y and add them together to a variable type of u long. So let's go ahead and compile this again. Wait for it to compile. Okay, open. Now, like I said before, when I type in this this number right here, 2147483, which we couldn't do last time, we can add itself to itself because it was too large and it wasn't inside the range. So 2147483, and we get the addition of it, which would be 254949672. So we could have actually used unsigned int, but we didn't to play it safe just in case it was larger. You may be thinking, why not just use the longest, the biggest integer type? Why not just use unsigned int 64? That's the largest. Well, that's because it's better to use precision. It's considered good programming to use the variable type that will be in your range. If you're going to use a variable type from 1 to 2 for like true or false, like if it's going, if it's not going, then you're going to use int. Why not use int? Or you can use unsigned int 16, which is up to 65,000. Or we can use unsigned int 8, which is up to 255, because we don't need all those extra numbers or all those extra possibilities. So if we're going to use a large number for calculations, I would suggest probably using a long, especially if the user can input what they want to input. Or if they're going to be doing decimals or anything larger than decimals that you want to be put into scientific notation, I would use double. And if you want to do it, it's long double as well. But if you can type in double or long double, it's the same exact thing. And for float, it's fractions, which I'm not very good at, I won't be covering. But if you want to experiment with it, you can. Let's go back into the program and actually erase everything and then rewrite it. So include so you can understand it. Pilot stream in main. We got to come up here using namespace std. Or I'm actually going to not space that out. And we already know we're going to have two different types of integers. What type of values do we want to use? We want to use, let's do unsigned, no. Let's do, unsigned short of that. Unsigned short x and y. Okay, so we already know we're going to have an x and y value. Basically, we're going to want x, y to add. So what do? We got to make a function. So first we want to put in an command in. The user's input x and then command in of the user's input y. And then we want to cow and out the x and y to add. So we got to make a function for that. Let's go ahead and end the code first. Return 0 system pause. Okay. Now that we have that, we got to make a function within this area. There we go. Function. Okay, so we got to make a prototype. We got to tell the compiler that you're going to use a function, and the function, you got to prepare to find that function. So, in prototype, and then we're using unsigned short add me, please. And we're going to use unsigned short proto A and unsigned short proto B. Okay, we have the prototype, and the computer's going to know that you're going to have the prototype, and if they see the prototype add me please with two parameters, then it's going to go for that function. So let's do unsigned short add me please unsigned short x unsigned short y. Okay. Now we have our function. We want to make it add together, so we're going to put return the x and, or let's do multiplication, x and y, which would be an extremely large number. This will give you a better idea on what I mean by the range of a number, because the value of this can only be within the unsigned short value. So let's go ahead and compile this by pressing F9 on the keyboard to do this. And since I'm recording with Camtasia, I can probably record the end. Alright, so once the program is started, we use unsigned short, which is within the 65,535. So let's do 5 and 5, which will come up with 25. Something at. Oh, we didn't make the add x and y. Good, and place that. We don't need to place in the integer type, we just put in x and y, because inside the int name we've already defined it as an unsigned short. So I'll run it. Make an end line here. Just realize that we're going to want that there. So compile it again. Okay, now open, we can only do 65,535 after that number. So 5 and 5 will get 25. Okay, 25. Okay, because that, you won't be able to get a value that's larger than that. So let's go ahead and let's make it 65,535 times 2. Oh no, let's do 40,000 times 2. Let's do that. 1, 6, take the compile. Okay. 40,000, and then times it by 2. If you didn't get the correct answer, if you pull up the calculator, 40,000 times 2 would actually be 80,000, not 40,464. The reason this happened was because it's not inside the value of this. If you wanted to do 40,000, you would have to actually make it a larger number. We use long. We use long for this, and we'll just type in long. Type in long. Long. And just keep doing this until you've covered up all the unsigned shorts. Long. Long. Okay. I think that covered up all the today. Okay. So we shouldn't get any errors when we compile this. Okay. So we were doing 40,000 and the long will actually cover that. So 40. And then times it by 2, we should get 80,000. Because it's within the range of the long. And if we were to do a value that ended up being larger than this, then we would have to go back and change it. But if we wanted to use two values, let's say the user's going to input two digits that are going to be within the long. So whenever 2 digits that are going to be inside, alright, let's say the user was going to input that. Let's say the user was only going to input a digit from 0 to 65,535. But the value of it can be larger than that. Let's say the value could be up to the unsigned long, which was 4,294,907, blah blah blah. And we want this to be able to output larger. We will just simply change from we would keep this as a long. We would keep this as a long because long is up to the value of 2,147,000,000 and etc. And we would just do unsigned short wherever we see the other long. So unsigned short. Go ahead and copy that. And this is the unsigned short because these two are unsigned short. I'm going to compile that. Yeah. Okay, so right now we got two variables that are going to only be up to 65,535. And then the value of it can be up to the long, which is 2,147,483,647. So we can get an extremely large number. So let's do 40,000. Let's do 4,000. No, let's do 40,000 times 40,000. I'm not sure what that is. And then let's see if that's correct in the calculator. 160 1, 2, 3, 1, 2, 3. Oh wait, 40,000 times 40,000, and it's correct. It matches up correctly, and that is 1 billion. So let's make it larger than that. Well, let's see what happens when we change it to the unsigned short. Let's see what happens. Because then we can only have a value that is within the unsigned short, which is 5,530, 35. So let's change that to unsigned short, and this one to unsigned short. Let's compile that again. And we should get it. We should just get a random number back because we're not inside the range. Let's say do 40,000. That's 40,000, and we get 4096. Now that's obviously not correct. Nowhere near correct. So let's change this back to long, and then this one back to long. And let's say we wanted these two to divide. So divide x and y. And I actually like to put parentheses around cases like this. So return x divided by y. And since it's going to be either a decimal or a fraction, I'm going to make it a double. So do double. It's going to return a double. And this one will return a double. So let's compile that. Alright, so let's do 22 and 7, which is 3. How many times is 7 going to 22? 3. And it's not giving you the leftover. Why is it not giving you the leftover? Because it's rounding the answer. So let's try what is it? It's float. Let's do float. Let's see how much I'm going to do float instead of a double. Compile. Alright, so we'll do 22 and 7 again. And we get 3 again. So what is the difference between a float and a double? Well, let's see. Alright, floats go up to that right there in scientific notation. So which one goes lower in numbers? Double goes lower because negative 308. That's an extremely low number. And the float goes negative 38. So that's an extremely low number, but it's not as low as 1.7 e to the power times 10 to the power of negative 308. So this one's 17 digits and this one's 15 digits. Hopefully you can understand what the difference is between these. But overall, the float is used for fractions, and double is used for other cases like decimals being rounded and stuff, and things like that. And let's go back to the main topic of function. Okay, so we got a function adding into it. What if we want another function, but it's not going to return anything, it's just going to do a command. We just do void add do command. Now remember, we have to place it up here. We don't have to place any parameters, but do command, and we're going to make it help hello. And we're going to do command. Oh wait, do command, and it should just do that command. We're going to compile it. Oh, we need the quotation, I'm sorry. the program was looking for a variable because it didn't have those quotation marks there. Okay, so we'll do 5, 5. It'll be 1, and then it spit out hello as that name. So what does void mean? Void means empty, in my definition, empty, no placement. Which means it has no place, it absolutely means, it just means nothing, it just means skip to the next word, basically. That's what I mean. That's what I think of whenever I see void. We can pull up on dictionary.com and see what void means, and it's, oh, here we go, here's a void tab right here. What void should mean. Void, void, void. If a pointer type is void, the pointer can point to any variable that is not declared with a constant or volatile keyword. When used as a function return type, the void keyword specifies the function does not return a value. So it does not return a value. That's the main thing. So this thing will not return a value as if this did. So we couldn't actually do a void and return a number really, but it has its benefits. Let's say we wanted no parameter. We could put in null. Actually, I don't know if we could do that. I've never done that. And we can't, but there's some cases, I can't think of any on the top of my head, where something would be null. Null means no value. Let's see if we can pull it up on here. Null. Take a second. Alright, the null keyword is a literal that represents a null reference. That does not refer to any subject. Null is the default value of reference type variables. Ordinary value types cannot be null. However, C#, that doesn't apply to us. Okay. We gotta rewrite it, and there's no other way to explain this, so I'm going to rewrite an entire new code explaining this. Include IOString main configure using namespace. See if I can make this video shorter. It is an extremely large video, but it is very informative. We're going to do int x and do an int y. Alright, and then n x and n y count. We're going to go ahead and make a count right here for what we want. Count is make y less than, wait, enter the number less than 7. Okay, we're gonna put a new line right there, and we're going to, they're asking to input an x and then y, and then we're going to put in a function right here. So let's do void command with no parameters, no params, the params. We can actually put that in. Okay, no params. And we're going to call the void right here, void, or command. Okay. And this is going to introduce you to something else new, but don't worry too much about it. It's pretty self-explanatory. So void command without any parameters, and if x is less than, well, let's go for parentheses, if x is less than y, then or then another block of code right here, then calc x is less than y, and putting a semicolon, and then right here we want to put in an else for if x is less than y, do something else. Then you want to do calc x is not less than y, and that should cover that. Actually, system pause. I'm sorry for the inconvenience on most of the errors on these videos, because I'm just winging it. There's no real way to plan out what you want to do, because you can just feel what you want to teach at the moment. So return 0, and let's compile this. See what happens. I think we might get an error. Okay, so we do need parameters. We do need a parameter. We need int param a, int param b, and then we're gonna put in x and y right here, and then int x, int y. Okay, that should cover that. Okay, then we have a program. Enter a number less than the second. So we're going to put in a 2. And then the number that's supposed to be larger than the 2 we're going to put in, which is going to be a 9. X is less than y. So x was less than y. And since x was less than y, we're going to calc. We're going to command out this string of text. So let's see, whenever x is not less than y, we'll do 9, and then we'll do 2. X is not less than y. Press continue. So hopefully that helped you with understanding functions. Functions are fairly simple, in my opinion, and they're really nothing to stress too hard about. But if you guys need a more in-depth tutorial on functions, I can make a 3.33 functions for Call C++, if you know the deal. We did cover a little bit of variables in this tutorial or demonstration, and I really didn't plan on that, but it did take up a lot of time, and hopefully by now you understand variable types and functions, and we can begin to create actual programs, and we can show you better techniques in the doing command lines, which are more precise and more exact. For example, we will show you, for example, what we've already learned that I want you to know is x and y right here. That saves 4 digits of coding, which is, and it saves you all those characters that you had to type in. So it makes your code more readable, and it's considered good coding to keep most of your commands on one line without having to press back. And one semicolon, I'm going to call it one line. That's 2 lines on one line. And it's considered good coding to be able to put command in and command y in one line of code. So that sums up section 1.32 I will see you either in 1.23 if it's created or requested, or I will see you in section 1.4